So yeah, we're going to talk about FreeCAD and how to get started with it. So mostly like I will try to keep it related to the Fab Academy course, of course. And so I'm going to try to talk really briefly about the background, then where to get it, and then most of the time spend on a demo, so on a presentation, so how to actually use it. FreeCADweb.org, so that's the FreeCAD website. Yeah, so this is the place where you can find it. So, but yeah, so here it is. So it's actually on the FreeCAD web wiki that, so it was started by Jürgen Riegel in 2001. Yeah, certainly there's a bit more. All right, but let's go back to FreeCAD. So yeah, so in order to get it, you have to go to this website. So when you click on download now, it's going to offer you to download the current stable version, which is 0.18.4. So it's just kind of old, and it doesn't contain the features that so most people are attracted to at the moment. So there are some really nice, cool features coming up with the new version, which is 0.19. So what do you have to do? So instead of downloading the stable version, it's better to go and pick one of the development versions. I have heard that they can be a bit problematic on Windows, so that there are some bugs. But I think it was for with one of the earlier versions. So now this is a pre-release version where most of the bugs should be fixed. So try to download and install this one. And in order to download and install, so you need to go to the assets part of the release and download one that is that fits your system best. So for Mac, choose the x86 64con.dmg. So it's going to be a DMG image, like an installation image, as for most of the other programs that you want to install. And so for Windows, yeah, there's a zip file. It probably includes exe file in there. But for Linux, take this app image, which is sort of a self-contained package, which is going to allow you to just run it without installing any kind of dependencies. So all the libraries that FreeCAD requires actually are included here in this app image. Yeah, with that in mind, so here I have the applications folder. It's downloaded here. So there's the older version, but we want the 0.19. And in order to make it run on Linux, you'll have to go to Properties and go to Permissions and check this checkbox, Allow Executing File as Program. And then you double click it, and here it is. Yeah, so before we dive in, so I would like to show you a few alternatives of what can you use for it. So for example, one of the alternatives is OpenSCAD. So if you're into, if you need like individual parts which are highly parametric and complex and mathematical, then this is a way to go. So instead of using user interface and clicking on icons, you use code in order to create these. And if you start out with it, then and use it on a regular basis, then all you need is this cheat sheet, basically. So the beautiful part of it is simple, and it's in its user interface. So there's just the code editor, and then there's the 3D part of it. And over time, you learn all these commands via this simple cheat sheet. And so there's no clutter on screen, so you don't have to look for some icon that is hidden somewhere in the menu or in the menu hierarchy. But so basically, you use you more like train your mind in order to remember these and get more flexible over time. And at the same time, it's also a very nice way how you can version control your work. So since if you're using Git, then this is very Git friendly, because Git was designed to primarily manage source code projects. So, and this is primarily, so it's going to be basically one file, which is going to be source code, and it's going to be very easy to manage it with Git. Another alternative is Solspace, which is really easy to pick up. So you open it up and you start drawing in 2D. And yeah, and then you can also easily extrude, and the way you specify these dimensions, it's very straightforward. But it has its limitations. It's also good for simple parts, for single parts. I have seen videos about how to do assemblies with it, but it's very, very nice when you need to, let's say, cut something quickly with a laser cutter, and you want that something to be parametric with certain dimensions and holes that have certain diameter, and you want to do it quickly. So this is the tool for it. The downside of this is that it doesn't contain, so it's not really parametric. So you don't have a panel where you can specify parameters and then reuse them as variables in design. But for simple things, really, you don't need that. And if you're more into research stuff and you would like to create something really mathematical, and you're interested in distance field geometry creation, then check lib5. It's a project by Matt Keeter. Yeah, you see, I know about lib5 much more than about FreeCAD, actually. So Matt Keeter is kind of the celebrity of Fab Academy in a way. So he took how to make almost anything course, and then he made antimony, which I'm going to talk about next. And so basically, yeah, now he works at Formlabs and designs user interfaces for them. So the user panels, like the touch interfaces that you see on the Formlabs 3D printers, which we have 2 of them at the lab. So it's mainly his work. And lib5 is a library and a tool that is built around the distance field paradigm, if I can say so, like the idea of, so the method of describing 3D geometry by using functional representation. And it looks very similar. So the editor, which is called Studio, it looks very similar to the one to OpenSCAD. So it's also on the left side, you have the code editor. So you have a certain amount of, a limited amount of commands that you need to learn. So it's kind of a little programming language. And then the interesting thing in terms of user interface design is that you can write code and you can specify parameters, which can be then changeable and editable in a visual like user interface mode on the right side of the screen, as you see in the video. And yeah, at the moment, it's very good for single parts. I mean, I haven't seen many examples where this sort of method has been used in really highly sophisticated CAD programs, such as Fusion or even FreeCAD, but I would expect to see something like this at a larger scale and more sophisticated in the next 5 to 10 years. And then this is the project that Matt Keeter did before lib5. So he's it's also an interesting. So it's also based on distance fields. I think this is the like an not so sophisticated version of lib5 in a way. So it's also, although I'm not really sure whether it uses here distance fields, but why it is interesting. So because instead of code on the left side, you have a node-based interface. So basically, the way you use it is so how you do it is that every thing is a node, and then you can also create custom nodes by using Python code and so on. And it's very similar to what was shown yesterday in terms of Blender, so that there's this node mesh node interface, which is a very similar way of creating 3D geometry. And it's all parametric, so you can change the parameters, and you could probably make a new node that reads these parameters in from text files and so on. And as for the assignment, so the way you do it in Fab Academy, so this is my documentation website. So this is the page where I did the computer-aided design week. And it's not just about CAD, although I'm going to focus on it now. But what you have to do basically is cover several options of CAD. So here I explore antimony, and then also, yeah, also Studio. It was already there back then, and then I explored Fusion 360 by trying to. So I kind of picked Fusion 360 to design a sort of a pre-version of my final project of the casing for the thing that I wanted to build. Yeah, I also explored the FreeCAD a little bit. And then I added some things. So right away, I didn't add like anything regarding raster graphics and vector graphics, but that's a requirement. So for the full, so in order to pass this week fully, you need to kind of demonstrate that you have tried out some raster, or let's say pixel, like image editing software, and try to make something with it. And then you also need to show one vector graphics software, so like Inkscape or Illustrator. So this is certainly more than you need, but and this is from a student. This documentation is made by a student last year, Wendy. So and she was focusing on Fusion 360, and she did a step-by-step tutorial on how to make part for her project. So, but let's continue with FreeCAD.
Quick question about the assignment. So do we have to use, so was the idea that we use multiple 3D softwares and multiple 2D softwares to do something, or like anything? Or
yeah, I mean, you have to focus on one. Like I would recommend you to start with FreeCAD or Fusion 360, but you have to show that you explored alternatives as well. Yeah, so you get a bit like a greater overview of what is out there, and yeah, maybe you find something that is really interesting for you, and instead of me, talking about FreeCAD, you actually choose something that is better for you. Especially if you have some previous experience, you might not necessarily want to stick with FreeCAD. But if you are just starting out, then I would recommend you to kind of at least consider it. Because I think if you're in a university, then it makes sense to spend time learning something that doesn't necessarily lock you in after you graduate. So with FreeCAD, you can keep using it for free after you graduate the university. But with Fusion, so even though you have the student license, so after graduating the university, the student license is going to expire. I mean, if you are really becoming a professional by then, and you're able to and willing to pay for the license, that's completely fine. But it might be that the company is actually changing their business model and kind of making it more expensive, and you cannot afford it anymore. But yeah, but the idea is that, yeah, you should focus on one, but explore other possibilities. Did this answer your question?
Yeah, sure. And both in 3D and 2D.
Yeah.
All right.
Yeah, but I mean, like, you can basically check Inkscape or Illustrator, then Photoshop or GIMP. Just make something simple in those, because that's these kind of programs, they're going to be important for the work in the next weeks, in the following weeks. And then CAD, I think it's important to start doing something with CAD, because it's going to be necessary for most of the weeks. Yeah. So and for FreeCAD, in order to demonstrate it, yeah, I think I should give a little overview what this is about. So when you open it up and you create a new file, this is what you see. I'm going to close this test file that I made for now. Yeah, FreeCAD is built around the concept of workbenches. So sort of you use different workbenches to work in the kind of the same 3D space. And if you imagine carrying a piece of material from the wood leftovers box to a table, then you maybe take a pen and you sketch something on it. Then you go to the room where the chisels are, and you use the workspace there in order to chisel off some bigger pieces. Then I don't know, maybe you go to the room where there's a lathe, and then you turn it and remove more material in a more precise way. So if you think about it like this, then probably it's the right way. So you basically use all these, you can use all these workspaces or workbenches in order to build something in 3D space. I'm going to focus on the part design workbench and sketcher and the spreadsheet workbench to enter parameters. But another useful thing is going to be the tech draw. So this is where you transform your designs into drawings. So for multiple reasons, one could be, let's say that you have a part that is really hard to manufacture at the university and you want to send it to a metal CNC shop somewhere. So you can use the technical drawing in order to describe the object so that they can make it for you as precise as possible. And then, so another way how you can make objects in 3D, so especially if they're more like related to interior design and furniture design and architecture, you could use the draft workbench and arc workbench. So these two are developing really quickly at the moment, and there are a lot of new videos coming out on YouTube. I think this Jorik from von Havre is the one who is behind the arc workbench, and he's publishing videos very often, and they are very descriptive and very informative. So yeah, I mean, this could be taught, and I think this should be taught in the architecture department, and it'll be interesting to actually explore it much more. But yeah, we're gonna, as I told, we're gonna focus on part design. So I'm gonna switch over to this one. And what you see here, so these are like helper icons, helper functions that are going to help you to navigate the 3D space. And in the 3D space, so I think this spinner over here, so this cube, navigation cube, it's very important because in CAD, it is important to think about how your part is oriented in 3D space. So it's important that kind of realize like how it is, because like how it is oriented, so where the front is, where the top is. So if you're modeling a box and the box is going to be standing on the table, so it sort of makes sense to follow these, so to make the box so that it's designed according to these directions in the 3D space. It's just gonna make your life much easier. So I remember I started out and nobody told me that and reminded me about that. And so I went through a few painful experiences where I realized that this is really important. But I mean, if you try and you forget and you run into trouble, then it's actually good, because then you're gonna remember and you're gonna be more careful about how you use this. Yeah. So there are some again helper functions. So this helps you to organize 3D objects in groups. So this makes a group, or this part specific. You can just use also folders like these groups, individual groups, instead of the part objects. So they're pretty much the same. It's just that I think the part offers you a bit some extra functionality within FreeCAD. And then there are the tools. So this is usually filled with tools that are related to the workbench that is currently selected. So for part design, it's this. If you switch over to Sketcher, it's that. But since we do not have any sketch that is active, it's all grayed out. And then for a spreadsheet, so you need to create a spreadsheet also to. So you see that there are the tools, but the 3D space, it should actually become kind of a spreadsheet if you want to do something with it. So back to the part design. Yeah, in order to start doing something, you can start either with the tasks that are in front of you in this tab. So on the left side, that's the combo view. It's a kind of contextual view. So depending on what you are doing and which workspace and kind of what is the state of the program at the moment. So this changes and it offers you all kinds of possibilities. So yeah, these tasks, it kind of offers you possibilities what you could do at the point. Or then in this model tab, you can see the structure of the model. So this is going to be filled up with all kinds of objects and operations as you go. So if you know Fusion, then sort of this is separated in two parts. So you can see the objects, and then on the bottom you have kind of a timeline. And here it's more like a combined view. So you have all the objects and operations in one place and all the history. So which is not necessarily following each other. So let's start with creating a body. So when you create a body, then so you see a body appears here, and each body in FreeCAD has an origin, so which is basically a set of basic objects. So like it's usually 3 axes, like X, Y, and Z axes, and then 3 planes, which is X, Y plane, like Z plane, and then the other one, which is YZ plane. And usually at the beginning, it's just hidden. So, and by hitting space bar, space bar toggles the visibility, not just of the origin, but of pretty much any object that you select in this bar, in this panel. Then for each object is also going to be, if you want to work on it, it's important to toggle it active, so kind of to set it to an active object. So once you have an empty body, so you want to do something with it, and the first thing is usually that you want to start a sketch. So that's a way of modeling that was very alien to me when I started with CAD, but it totally makes sense. And if you kind of roll back the history and you kind of think about how the engineers actually were doing stuff in the past. So they would be drawing something on paper, and then these paper sketches were somehow manufactured, and then you roll back, the ways how things were manufactured, and probably something was cut out from something was extruded through a template, through a stencil, and so on and so on. So so all these kind of things are more or less built on the history of engineering in a way. So yeah, when you start out, you start with a sketch, and you have to select the plane, and so I'm just gonna select the XZ plane for now. And in the sketch, you're given a few things to start with. So these are the 2 lines like axes, and then also like a center point. And you can draw objects, different kind of objects with these. So you can put points, you can draw lines, of course, circles, rectangles, polylines. By hitting M, you can also change the mode of the polyline and things like those. And then on top of those, you have the constraints. So like for example, the coincident constraint is going to make 2 points to stick together. So this is not the best example, but here, like for example, you can make these 2 points stick together like so. Then this fix a point onto an object, or like, this is more like, I don't know how to call it. I think in Fusion they had a really specific name for this, but basically what this does, this makes, if you select a point and a line and then set it up by clicking the button, it's gonna make the point stick to the line at all times like this. Then there's a vertical constraint, so I can select a line and click that, and it's gonna make it always be vertical. So whatever you do with the points, with the lines, so it's always gonna stay vertical. Then there's a horizontal constraint. So this one, so you click on this, it makes a line horizontal. Then you can select 2 lines. So also so in these kind of programs, usually it is that you can continuously select objects. You select one line, you don't have to press any control or shift or anything. You just select the next object that you wanna work with. And in this case, we can make a parallel constraint. So, and this is gonna make the two lines parallel. Then, yeah, so another thing, for example, here we can select these two lines and then we can make them perpendicular. Yeah, I was really excited when I discovered that you can use software, like a graphical software, like design software in this kind of a way, because I thought that my geometry knowledge from high school and also from the primary school, that I'm gonna never use it in my real life. So I never, so maybe like when I started to play around with Macromedia Flash, then I used a little bit of trigonometry in order to figure out some distances and you know, like to create simple easing functions and so on. But I never kind of thought that, oh, you can actually use this like you see it now. And well, once I read more and more about it, then I actually realized that all the software, the graphical editing software, so before that was invented, so this was more or less the way how computer-aided design interfaces were imagined and built initially. So this, so around these kind of paradigms, if I may. So yeah, and so this is basically defining relationships between objects. So it starts out with simple objects like dots, like points, and then they become lines, then they become arcs, and you can specify relationships between them, like radiuses, distances, and so on. Yeah, and then, for example, so the next one that I want to talk about is this tangent. So you can select two, like a line and a circle, and you can make the line tangential to the circle like this. So it's always gonna stick to the outline of the circle. Then there's an equal constraint, so you can select two lines and then make them equal. And also, like these kind of things, they're not just limited to FreeCAD. So this is what you can find also in Fusion 360 or in SolveSpace or in SolidWorks. So all the computer-aided design software packages. Then this is a symmetry thing that you, for example, if you want to make this to, or let's say this square. So now we, not square, but like a rectangle. We want it to be in the center, kind of symmetrical to this center point. So what do? You select one point to one extent and the other point to the other extent, and then the midpoint around which the symmetry is going to happen as the last one, and you select the symmetry constraint, and it's going to make it all like symmetrical like this. Then what do we have here? So it's a block constraint. I never use it. I don't know what it is. Then lock constraint. So that's probably going to be, so when you want this line to be here for whatever reason, you want it to stick there, then you select one vertex from the sketch other than the origin. Okay, so we need to, so this is like really, it's working on the, yeah, on the vertex level or point level. So I'm going to go a step back over here. Yeah, and as you saw, it actually works in a way that it just specifies certain dimensions from the point of origin here in the sketch. Then, so this becomes a bit more easier to understand. So there's a dimension, so you can enter like dimensions. The default unit in FreeCAD is millimeters, so it's going to be, oh no, so something happened. So yeah, sometimes crashes. And this is also what you should expect with FreeCAD. So it's free and open source and actually very flexible, and you can build all kinds of nice things with it. I mean, if you're considering open source and let's say you really want it to be usable and editable somewhere else in the world where people maybe are not so lucky and cannot get Fusion 360 right away. So, but they can get FreeCAD for free and they can use it. then I mean it's worth the effort. So you can create a design and then send it over there, share it online with everybody, and there's going to be a increased amount of number of people who are going to be able to open your design, actually work with it. Yeah, so more about how this goes in a bit more practical demonstration. So yeah, once you have this, then yeah, you can do all kinds of things like extrude and subtract and all of this. So, but yeah, I'm going to cover this as we go with the actual thing that I want to do. So what I did is I created a kind of a hypothetical PCB that could be a project, but I'm sure it's not going to be so simple. So there's a microcontroller, a capacitor, two resistors. So this was done in KiCAD. And what we would like to do is to create a case around it. And so many different ways how to do it. So you could use a case where you can slide it in, or you can create a top and bottom, so which is probably less elegant, but this is the way how I chose it to do today. And what I'm going to do, I'm going to start out with creating little pads on the bottom, and then I'm going to create a floor, and then the walls, and then the top part of this. And I want just to demonstrate to you how you can use an existing object and build things relative to it. And yeah, as you see, you can just hide and unhide it. Select this body, the previous empty body, and just delete it. And it's a good idea also to save your file somewhere and save it regularly. As you know, like FreeCAD is better, getting better, but it still crashes sometimes. So you just keep that in mind. But it doesn't mean that it's bad. So, and we start out with creating a body. So I'm gonna create one of those pads over here. Now, and in order to do that, I'm gonna need some sort of a reference for the circle over here. And I'm going to use an element or like a function which is called the shape binder. So like this is a shape binder object, so which is able to bring geometry from one object or from one body into another body. And when you click on it, it's going to ask you to add geometry. So you can add a whole object, and then you can also add separate elements of that object. So when you click on add geometry, it becomes active. And what you need to do, you need to select the geometry on the object that you want the geometry to come from. And as you see, this automatically got filled. So the name of the actual part went to the object field, and then the actual line or edge of the geometry got listed in this list over here. You hit OK, and here you have your shape binder. So now when you hide this, you will see that this line is visible, and you can use it geometry to build on top of it. And it's also a good idea. So once you start working from the shape binder, to hide the original object, because it's going to make your life a bit easier later. So then you select the shape binder, and you can use it to create a sketch. So you select it, and then the sketch, and basically it should offer you to, should this be visible? I don't know, I'm running in this error. Or I'm going to select this face, and then I'm going to create a face, yeah, a shape binder from it. And then I'm going to hide this. And then I'm going to create a sketch. Yes, now I think it was not listing this as a plane because an edge alone cannot be a plane. So I had to select the bottom part of the circuit board in order to make a shape binder that is more like a plane. Now I can select it. And now the FreeCAD automatically switched over to the sketcher mode. And this is where we can use all the tools that I demonstrated a minute earlier. And a very useful tool here is this one, which is basically able to project the geometry into the sketch from any outside, not really any outside, but geometry which is within the same body. So this is why it's important to create a shape binder which kind of copies or references geometry from other objects. So in order for you to be able to reference it in the sketch. And now I'm gonna right click here in order to disable the tool, so this projection tool, and I'm just gonna draw a circle by using this tool. And I have activated a feature in the preferences, which when I hover, it's going to offer me kind of the most likely constraint that could fit in the current context. So when I hover this point, then and the first object that is going to be placed, there's a point that then FreeCAD is going to offer me where I want to make a coincident constraint, which I do. So I click and I start a drag, and I'm going to create a circle like this. And when I try to move this central point, you see it's not going to move. So it's fixed in one location. The next thing is that I can specify the radius of this one. And this is one of the constraints that I didn't mention before. And we can enter a value, let's say 2 millimeters. I guess I need to restart FreeCAD. Here we go. Let's go back to the sketch. And here, it's just going to select everything and delete it for now. Okay, once more. So I'm referencing this one. Going back to the sketch. And then here. And then selecting this. And then the radius. Yeah, the millimeters are back. There was something with millimeters. And yeah, so this is 2 millimeters. The radius is 2 millimeters, so it's a bit bigger than the hole. That's okay. And then from this point, yeah, I close the sketch. So here you can, in this panel, you have to click close in order to come back to the part design. And then you can use the pad or extrude function of it in order to actually get a 3D object out of the sketch. And yeah, here it's gonna extrude it. So you have several options or what to do. So how this extrude could happen. So it can have 2 dimensions, so starting and ending dimension also, or it could be relative to a face of the same object. So let's say, or a face of another object if you use this shape binder. But you're going to stick to dimension for now. And the length is going to be 1 millimeter, and I will hit OK. So at this point, you would probably start to think about, so how do I make it parametric in order to change it later if I choose so. And it's a good point where you can start thinking about that. And in order to do that, we can switch over to this spreadsheet workbench and create a new spreadsheet. And let's say, and enter a few and create a few variables. And the first variable is going to be pad diameter. And this is nice. I like this spreadsheet because it's much more flexible than the way you enter parameters in Fusion. Maybe they're going to come up with a better way, with a better interface for the parameters in the future. But this, in this one, you can organize your parameters as you want. And you can make it bold. So, example. And then the thing that you need to do, so when you enter a value somewhere, so you do not necessarily need the label, but you need the value, but you need also to set an alias of the value. So you right click, you click properties, you go to alias, and then you enter the name. And notice also that when you try to add a space in the variable name, or FreeCAD is gonna tell you that it's wrong. So you can use all kinds of tricks here. No, not the minus, but underscore. So you can use. So this is snake case combined with camel case, but I prefer to use camel case here. So with starting capital letter. So pad radius, you hit OK. And another thing is going to be pad height. Like if you're like in terms of the label, you don't need to use the same rules as in the alias, because this should be understandable for humans, for us, so for you. And this part, the alias, should be understandable by the computer. So now we have two parameters here. I'm gonna hit Control Save to Control S to save it and go back to this the 3D view over here. And I'm gonna open up this history over here. So here you can also start to follow up. So how the object is built. So the body, it contains an origin, and there's a shape binder. And once you build the object, then FreeCAD is gonna hide all the unnecessary things in that object or in that body and leave only the one that is for you necessary to see. And in that pad, there's a sketch, which is also hidden from the view, but you can also make it visible by hitting space. And I'm going to double click on it and open it up. And what I want to do, I want to change this radius to the value from the spreadsheet. And in order to do so, you double click. And then there's this blue icon over here, which when you click, it's going to open a formula editor. And you can enter mathematical expressions here. So for example, you can 2 millimeters times 2. It's going to give you the value. Or you can reference a value from the spreadsheet. The spreadsheet is called like that, the spreadsheet. So you can also rename and then use the different name in there. You start with spreadsheet and the dot, and then it's going to offer you a list of variables that is available there. So pad radius. Okay. It's gonna now give you the value from the spreadsheet. And if you go back to the spreadsheet and you change the value to 2.2, let's say like this, save and go back, it should change to that value. If it doesn't change right away, then double click and like in one state or another, eventually it has to change to the value that is in the spreadsheet. And here we can close. In the same way, we can also edit the pad. So edit the amount of extrusion, so the distance of extrusion. So you can double click on that. And here we see again the blue icon. So wherever you see it, that means that you can actually open the formula editor and really start referencing things like so. You saw it also changed in the view over here. You hit OK, go back to model view. Okay, let's see how it looks in context. So I'm gonna click on the imported object, so the PCB, and hit space in order to show it. And as you see, I'm viewing it from the bottom, but that's exactly what I want. So the pads of this, I want to be on the bottom. So what next? So you see that there are holes, and I would like to have a hole, or like have some sort of a screw going through both of these planes, so both of these objects. So I could use nails and just hit it through, but the more elegant way is actually to use a screw. So I could stitch these two pieces together, so with other pieces that we're gonna model in a minute. So in order to make that happen, we will need to click on this and create a new sketch on top of it. But in order to do that, I need to switch back to part design workbench. And yeah, so you can select the create sketch from the tasks tab, or you can just select it here. And we can again use this one in order to reference the circle. And also in sketch mode, it's free to rotate the 3D view. It sometimes can be not what you want, but sometimes just to make sure that you are referencing the right parts from your object, it's nice to rotate and select the exact part that you want to reference. And then you can hit this in order to go back to the view. I think there's another way. You can hit this one also. And here we are going to create another circle. And what we want to do is to snap it to the actual circle that is underneath here. How do we do that? I will hit close here, and I will hide the model. And we know that we create a shape binder over here, and now it's invisible, so we can make it visible. And we could actually reference this line from the shape binder into the sketch. So I'm going to double click on the sketch, and I'm going to rotate it around, and we'll use this tool in order to reference this. And it proves itself to be tricky. So I'm going to close it again, and I'm going to hide the pad as well, open the sketch, and then it actually worked. So it actually referenced it here. So very good. And what we can do, we can select this circle, that circle, and make them equal. And another thing with sketching is that what you want to do, you want to make your sketches constrained. So you want all the lines to turn green. So which means that FreeCAD, so the solver, and in the background, it doesn't have any questions left. So because it might happen if your sketch is not fully constrained, then FreeCAD opens it and it decides to change some lengths of the lines or angles in an unpredictable manner. But if the sketch is constrained, that means that nothing unpredictable can happen. So since it's based on the constraints, so you need to make sure that there are enough constraints to limit the movements of the dimensions of all the objects that you have in the sketch. So now I'm going to close it. Reveal the pad again, hide the shape binder. Now, with the sketch selected, I'm going to select this create pocket with the selected sketch icon. And it's gonna create a pocket. And here, if you change the dimension, you will see that it's doing it only halfway. And so let's say if we change the parameters in the spreadsheet and we change the height of this pad, then it might be that this exact dimension is actually not matching. Of course, we can use a parameter here, but there is a way how to make it always go through, and this is by specifying the type through all, like this. And then you hit OK, and here's your pad. Let's show it. OK, so this is going to be your pad 1. And next, we're going to create a second pad. I'm going to do this faster. So I'm going to create a body, then I'm going to create a shape binder. I'm going to add a geometry. I'm going to select this one, hit OK. And I'm going to hide the original, and then create a sketch on top of the shape binder. Again, I did the same mistake. So instead of just the circle, I want to select the whole face. So I'm going to go to the body, create a shape binder, add geometry, and click on the face, and OK. And then I'm going to hide the original object. So, and then I'm going to select the shape binder and click on New Sketch and select the shape binder as the surface and reference this one. So this time, I'm going to create it a bit differently. So I'm going to create 2 circles, 1 and 2. And for the first one, I'm going to make them equal. And for the second one, I'm going to specify the dimension that we specified in the spreadsheet. Pad radius. OK, OK. And as you see, all the lines are green. It's fully constrained. You can close it. And then I hit on the pad. And for the pad, I'm also gonna use the parameter over here and hit OK. So, and instead of doing it in 2 steps, I was able to do it in 1 step. OK. I'm going to rename this to pad 2. 2 pads and the board. How about we create like a floor for it? Now, so we want that floor to start where the pads start over here, right? Okay, let's get there. So we create another body for the floor, and of course we want another shape binder. And for the geometry, I'm going to select the bottom of one of the pads and hit OK. I'm going to hide the pads. And also for the floor, I will need to reference the geometry that is on of the board. So I'm going to create another shape binder. It doesn't work like that. And hide the original object. So now we have 2 shape binders in the same body that we can use to reference, that you can use to reference in our sketches. And I want to select the shape binder Aalto in order to create a sketch on it. Yeah, here I need to make sure that I remember the name, and OK. And here I will need to project the outline of it. And I click the right mouse button in order to exit this tool. And yeah, there are several ways how to do it. And one way is to draw line by line, or you can use the polyline over here. And when you start drawing, then you see these icons next to the cursor are going to appear. And this horizontal line is basically telling me that if I click now, it's going to apply a horizontal constraint to the line, which is what I like. Another thing is that when you hit M, then it's going to change the mode of the line. So you want to have a round corner. So one of the modes is round corner or an arc. And you can go here. We're going to apply the horizontal and vertical constraints in a minute, like so. So let's take care of the rest of those. So when you select a line like this and click the icon, that's one way how to make a horizontal constraint, but not a vertical constraint, but you can also hit V on keyboard. V for vertical constraint, and then H for horizontal one, like this. And then you want to make all these lines equal. So the horizontal ones equal. And for that, I think you can also hit the E key on the keyboard. And I'm going to make these vertical ones equal as well. And what we want to do here is like another interesting thing is that you can see all the constraints over here. And if you really need to, you can unselect or delete them individually over here. And it really makes sense to do it slowly at first, because FreeCAD sometimes can get very crazy about constraints. And the general rule of thumb in FreeCAD is to try to keep your sketches as simple as possible, and then build on top of them, on top of the objects that you create from them. Okay, so here we have floor part, so which is more covering only the bottom of the circuit board. So, but this is not really what we wanted. So I'm just gonna go back here and undo what I just done. Basically, what we wanted to have some offset from these edges over here. So I'm gonna make these 2 points vertical, these 2 points vertical. These horizontal. Yeah, I got a little bit lost, to be honest, but no worries. So this seems to be good enough already. This is not necessarily the best way how to do it. But yeah, so as for the features is that you can use also construction lines. So these are going to be the visible lines that are going to be taken into account. But you can create a construction line by clicking on that to toggle it. So construction line is going to be displayed as a blue line over here. And so let's snap it to this point over here, and it's going to automatically apply also vertical constraint. And what I want to do is that I want to create one over here as well. And I want to make those two equal. Yeah. But now I am not sure why it actually is displaying it as constrained, because it should not be.
Excuse me, Chris.
Yep.
Could you say it again? What are you planning to design for now?
Yeah, like a little case for the PCB. So basically, if you look at this PCB, I want to build like a little case around it. So now this is 1 millimeter, and I want to check if it changes together. Okay, so this is something that I was aiming for. What I would like to do is also to make this as a parameter. And what I will need is a gap between the circuit board to the wall, and then the thickness of the wall. So I'm going to create 2 parameters here in the spreadsheet, which is going to be wall thickness. It's going to be 1.5, and then wall distance, which is going to be something as 0.25, a quarter of a millimeter. And here I'm going to specify the alias, and here as well, like so. Save it, go back to here, and replace this with an expression. It's going to be the wall distance plus wall thickness. Okay, here we go. Now it changed. And now I can close this, and I can use the pad function in order to pad it downwards. And here we realize that we need either a new parameter, which would be the floor thickness, or we could reuse the wall thickness, but I would rather go with the floor, which is going to be 2 point. No, it's just going to be 2. alias floor, like so. And I'm going to click on this blue icon to specify the extrusion amount as the parameter that we just created. Okay, and now I can unhide the rest of the objects over here. And this is pretty much what we have at the moment. Another thing that we want to have is holes here. So in order to make them happen, so I'm going to open up the body, which I'm going to rename to floor. And I'm going to hide it because I want to reference these circles one by one. And here's another kind of shape binder that we can use for the purpose in order to avoid you creating sketches for to this negative padding or pocketing. So I can select this and then this sub-object shape binder, and it's gonna create me plane over here. So for some reason, this is a bit less flexible in some cases as the normal shape binder. So if you want to use a shape binder to put your sketch on top of it, then so the original one, the old one. So this is the one that you're going to find in the older version of FreeCAD, which is also fine to use. And then this is a new feature, and it's really hard to explain the difference between those two. But I think like with the old shape binder, so if you move the original object, so the shape not necessarily moves together with it. So, but this one, if you move the previous object, it moves with the object where you specify the shape binder. But yeah, for this context, you can create, so it creates a binder that can be used in order to extrude or cut objects. So what I just did, I unhided the pad, so kind of the resulting object of the floor. And I'm going to select the binder and then click on this pocket button over here. And yeah, you see it did create a pocket, and I'm just to make sure that it cuts through, I'm going to select through all and hit OK. And I'm going to do the same with the other one. So I'm going to select this edge over here and then create the shape binder, go and unhide the pocket, select the shape binder again, and then hit on the pocketing tool and select the through all as the option. All right. So I think I'm talking around an hour already. So what I wanted to achieve was actually this. And the way I did it is actually by creating another. So this is a bit, so yeah, Pcb container here. So I use this Boolean operation over here. So so I created a wall by specifying a sketch like this. And here I used the wall distance in order to create a line, so to make the wall to be a little bit offset from the PCB itself. But I think that I managed to explain kind of the basics, how you can build 3D geometry based on an existing object. And throughout the course, I'm going to try to figure out some new examples and demonstrations how to actually do that. Of course, there are so many things that yeah, it's not possible to cover in 1 hour. That's it. Yeah, thank you very much. And Have a nice weekend and see you next week.